Hello, my name is Patrick Simmons, and I'm an applications engineer supporting position sensing products. In this video, I will elaborate on the different rotation functions in TIMS. In a prior video, we showed how a joystick like this could be simulated with the joystick function in TIMS. While that video showed one approach, in reality, there are multiple different tool functions that could have been used for simulating such rotation in a system. The functions including joystick, hinge, and rotation can all be used to simulate rotational or arc path movement. This video will help you differentiate how these functions operate and help you understand when one may be more convenient to use. To understand the difference, let's use a diametric magnet so we can easily see the movement for each function. Here we use a TMAC5273 at the default sensor location. Starting with the hinge, we see that the magnet tilts 30 degrees away from the z-axis around the x-axis in the YZ plane. As for the joystick function, the magnet also tilts 30 degrees away from the z-axis, but in a direction that is 15 degrees away from the XZ plane as specified in XY angle entry. As for the rotation function, the magnet rotates 30 degrees around the z-axis. One detail to emphasize here is that the sensor and magnet had the same coordinate positions defined in each simulation. The only thing that visibly changed is the axis the magnet rotates around. While some effort is required for translating magnet sensor orientations and positions to different tool functions, it does provide some convenience on what makes most sense to you relative to the coordinate system used in your mechanical drawing. Additionally, this can be a convenient feature when you may need to consider other aspects of your design. For example, let's assume you did an initial simulation in TIMS to understand the signal behavior for this movement. Assuming you started with the joystick function, how might we extract this alternate movement behavior? If we stayed within the joystick function, you would need to do a parametric sweep and then post-process the data. Alternatively, with a little geometric calculation or simple CAD program measurements, you could determine relative magnet device spacing and orientation, then run a simulation in rotation. While it's not an option to switch functions after reaching the main design screen, there is a quick workaround. You simply download, modify, and upload your JSON file, which is time-saving if you already selected multiple devices and have sweep parameters already defined. You can do this by downloading the JSON from your initial file and downloading a JSON from an example design with the function you want to use. You then change the function, magnet movement, and sim settings portion of the code to match the example file. Thereupon, you save your revised file and subsequently upload the revised file. Before closing out, let's look at one more example. What if you want to do a wheel configuration like this, but at some random XY angle? How would it be done? This would require the joystick simulation function. After setting the magnet x-axis or y-axis angle to 90 degrees, you can set the rotation axis by observing the xy angle relationship listed in the table at the bottom. That concludes our discussion on the different rotation functions and how to switch between them. To learn more about TIMS and TI's magnetic sensing devices, please see the relevant collateral linked here.